Okay, I messed up my video a second ago and I had to delete it, so I'm just going to kind of talk through these notes that video explained. First of all, if you have x to an even power, x to the 2, 4, 6, 8, those all look kind of like parabolas. You have x to odd powers, they all kind of look like this cubic function here. We say, well, based on this, if I have limit as x goes to infinity of x to the n, if we look at that, on both the kind of quadratic looking and the cubic looking types, as your x's get very big and positive, the y's head up to positive infinity in both cases. So that leads us to limit as x approaches infinity of x to the n is infinity. If we look, when n is even, then the y's, when you look at x to the negative infinity, the y's approach positive infinity. But when n is odd, the y's approach negative infinity. So the second statement says if n is a whole number, because this is going to be based on whether the number is even and odd, and decimals aren't even or odd. So if n is a whole number, the limit as x approaches negative infinity of x to the n, it will be infinity if n is even, because that's parabola shape and that heads upwards. And it'll be negative infinity if n is odd, because then it'll be a cubic shape and this part will be heading downwards. We say, well, what about x to the negative n's? Well, limit as x approaches infinity of...
Please pardon this interruption. Teachers, one last time, let's check those
Okay.
yellow schedules. And if you have students in your classroom that can't show you a yellow schedule, please send them to the old front office. Thanks.
Okay, so limit as x approaches infinity of x to the negative n. This is limit as x approaches infinity, 1 over x to the positive n. Well, the limit as x approaches infinity of x to the positive n is infinity. So this turns into 1 over larger and larger numbers, which will lead to smaller and smaller fractions. So this approaches 0. And we get a similar thing for x to the negative infinity. X to the negative n equals limit as x approaches negative infinity of 1 over x to the positive n. And these in magnitude, they're getting larger and positive if n is even. They're getting larger and negative if n is odd. This still leads to 1 over something that's getting larger and larger and larger and positive, or it's getting larger and larger and larger in magnitude but is negative. And that will lead to smaller and smaller and smaller fractions that are positive or negative, which will approach 0. So we're going to apply this to a couple of the examples in a minute.